Hi people. So today we'll be doing construction geo. So like just as an example of this, so you know what it is, it's like the INMO 2023 problem 6, like this year's INMO. So essentially what happened in construction geo, you are given some weird sort of tools and you are given something and you have to construct something. So essentially you can like say that you can create things with these tools. And you can say that like you're just basically forming a structure. So like sometimes in a problem you're asked to construct, let's say, so we'll talk about one structure just to see what I'm saying. So suppose you have a tool. What it does is you have 2 points, P and Q. It will construct the perpendicular bisector of these 2 points. This is what it does. And this perpendicular bisector extends infinitely, like it goes till infinity, like as long as you want. But you cannot mark any length on it or something. So what you're given is you're given 3 lines and there will be like 3 non-parallel lines. So there will be a triangle formed by these 3 lines, call it ABC. You have to mark the orthocenter of this triangle by just using this tool. So obviously you cannot do it like directly in one go. So like even if you try to take, let's say, draw a perpendicular bisector of BC, the most natural occurring points in this configuration. Okay, we draw a perpendicular bisector. Okay, nice. We get the midpoint of BC. But how do you relate it? Or there are more things which you can do with this thing. And how do you do them? So you have to mark the orthocenter, right? So the idea is you just use this tool and like play along with this tool and see whatever you can construct and use those things to finally do the problem. And sometimes in a problem, you can even do more than what is stated. So like this is a famous problem, like people would know this, Elmo 2020 P3. And you were asked to construct orthocenter, but eventually you can even show that you can construct other centers. And this perpendicular bisector tool is better than a straight edge. So what does it mean for a tool to be better than another tool? We'll talk about that also. And I think this was in Pranjal and Rohan both, right? I'm not wrong. Together. So yeah, they found this thing. Okay, so this is like a kind of hard example. So we'll start with easier things first. So we'll start with few theorems in construction geometry. Okay, it's just one. It's called the Consulate Sineathon theorem. It sounds fancy, but it's nothing as such. It's just a cute result. So what it says is, suppose you have a circle and its center is marked. And this is what you have. And you have a straight edge. So using these two things, so basically if you have a straight edge and a circle marked with a center, you can do everything which a compass and straight edge can do together. Okay, so one question which will arise is, can you draw circles? Obviously not. So you can say it like, what do you need circle for? Like, suppose you have a circle and you have another circle. What is the use of these two circles? Like to see the intersection points in some way. Like a circle is not explicitly needed. You just need points on that circle. So if I can mark, so let's say I define a circle this way. You are given a center and any point on the circle. Then I can define the circle by just these 2 points, right? Like put a compass on A, open it till B, and you draw the circle. So if I show that just using a straight edge, suppose I'm given a line, like you can draw lines using a straight edge, right? So suppose I can draw intersection of this circle with the lines. Then I just don't need the circle, except for like, let's say, aesthetic diagrams. I don't need the circle explicitly, as long as I can mark the intersections. So that is what this theorem means. So is the meaning of the theorem clear? Like what it's trying to say? Yes, no, or any doubt? Nice. Okay. So let's see, how do we do this? So the basic things which you need to do any construction is basically, can we reflect points? Yes, like just a second. So okay, so someone is asking, can we reflect points? So if you have a compass and a straight edge, you can obviously reflect points, right? Like let's say you take this point and you draw the perpendicular line from this point and you mark stuff and like you can construct the reflection, right? So what this Consulate Sineathon is saying, if you have a circle with a center mark, that thing and a straight edge, you can mark the reflection of this point. So we'll see how. One second, I'll just close this point. Okay. So let's see how do we go, like how do we prove this? So basic things in a construction which you need are, if you can draw lines, if you can draw circles, if you can mark intersection of two circles, intersection of a circle with a line, and intersection of two lines. So these are the basic things which you need to do a construction, right? So now you have a straight edge. So what you can do, you can construct lines. You can obviously not construct circles, and we do not need them. As I said, like we will show that we can mark points on circles and their intersections. And you can obviously mark intersection of two lines because you have straight edge. So just take one line and extend the other line. You can mark the intersection. So now let's go about proving other things. They're not that as direct. So we'll start by some basic things. So one intuition which you can take from this is, you have a circle. Like there is a reason why a circle is given, right? And let's say you have a circle and a line very far away from this. So how do you relate the circle with a line, right? So one idea can be like, let's say you take the center and take 2 points on this line, A and B. You just scale this line to the circle in some sense. Like, let's say this is point A dash and this is B dash. You can do this. Or if you can construct parallel lines, then maybe you can try to do this. Like, just try to take that thing, whatever you have, to the circle, do the stuffs in the circle, and then take it back. So as we do the things, it will become more clear. Okay, so I'll just state the first few KMs, and you can try to prove them. Like, they won't be that hard to prove. Okay, so suppose you're given a line, like essentially 2 points, A and B, and midpoint of AB is marked. I give you another point P. Can you construct a line parallel to L passing through P? Only using a straight edge. You don't even need the circle for this thing. Okay, let's just do it here. So you need to construct a line parallel to AB passing through C. Okay, so the problem is essentially like, you have a circle with a center marked and you have a straight edge. And we want to show that is equivalent to, like, so if you have a circle with a center and a straight edge, you essentially can do anything which you can do with a straight edge and a compass. So we're trying to prove that thing. And for that, the first lemma is, so you have 2 points A and B, midpoint of AB is marked. You want to construct a line parallel to AB, which passes through C. Oh, 1 second. I assume you cannot see my screen right now. Let me start. Okay, my screen is visible at this moment, right? Oh, please tell yes or no. Okay. Yeah, GeoGebra only. Nice, thank you. Yeah, so like any ideas how we'll go about proving the parallel lines? मैंने lost idea. Yeah, fine. Okay, yeah, that one. Fine. Okay, so let's just see. Suppose you had this parallel line constructed. You want to construct this line, right? Like, let's just make it dotted. And let's say you want, like, what do you need to construct a line? You need 2 points on that line. Suppose you want to construct this point like D. So what do you like? You have these 4 points and midpoint of one thing. So can you make any synthetic observation in this thing? Like by adding some new point or something? Okay, so the thing is, this is basically like a trapezium, right? And what do we know about trapeziums with midpoints? So if we extend these two things, oh wait, someone was speaking, go on. Okay. Then this point and this line passes through midpoint of CD and AD cap BC. Like, is this clear? Or like, why is this true?
Could you repeat?
Okay. So suppose you have 2 lines, AB and CD, which are parallel, and you're given midpoint of AB, M. So then if you construct this point E, which is AC intersection BD, then the line EM passes through midpoint of CD, right?
Yes.
And it also passes through AD intersection BC. Like, if you don't say, just ask, I'll just tell you the proof.
Yeah, I got it.
Nice. So we'll use this fact to construct this dotted line. So what we do essentially is, we just extend the line AC. We take a random point D on it. Or let's just say this point is X. And you construct BX. What will be the next step? Like you want, so basically in this thing, you need to get this point. BX intersection this thing. How do you get this point? Go on, someone else.
We intersect XM with BC and draw the line through that.
Yes. So we know that like, let's say this point is D, we need to get D. We know that AD cap BC lies on XM. So we draw XM and we know BC. So we mark this point. And now this line will contain the point D, and so does line BX. Yes. So that is how we get D. And now CD will be parallel to AB. So is this clear? Okay, 2 people said yes, more people. Like, if at any point it's not clear, you can ask.
Yes, it's clear.
Okay. So what do we have? You have AB points and midpoint of AB is marked. Then you can construct line parallel to AB. So the next natural thing which will come is, how do you mark midpoints? Like, suppose you are given a line. So you want to construct a line parallel to this thing. Like, you will be motivated to construct another line, right? Through this thing. I give you 2 points, A and B. But what do you need to construct a parallel line? You need midpoint of AB, right? Like A and B can be any two random points. So how do you go about that? Like, how do you get midpoints? So, given a line L, construct a bisected segment on L. Or alternative, you can think of it this way. So let's say I give you a line L, and if I have A and B 2 points, if I can reflect A over B, let's say A dash, then also I get a bisected segment, right? Like B is midpoint of A dash. Then also I can construct a line parallel. You can prove either of the two things, and the proof is like almost identical. Okay, I'll just tell you, for this thing, you'll need the circle. Take 3 minutes to think about this. Like, how will you construct a bisected segment on this? Okay, let me know like when someone wants a hint. Like, I'll give 107.23, but if anyone wants before that, it's fine. C1, C2 line will be OC, right? Malay. AC, I mean. Yeah. AC. Let them intersect at D. Okay, yeah, almost seems correct. I think I have something different in mind, but yeah, this also works. Okay, so as for a hint, what is the most natural line segment which you can draw in this thing, line or line segment, where you know that there is just a bisected segment? Like, basically, you need 2 points such that you know the midpoint of those 2 points. For surety. Like, anyone? You have these things in, like, you have only this much thing under straight edge. How can you construct a line where you know 2 points whose midpoint is marked?
Like the diameter?
Yes, exactly. Like you have a circle. So you just take a diameter. Sorry. You know the midpoint of this is marked, right? So in some sense, you need to translate this thing to this line. That is the basic idea, right? That is how
I
you'll
think
use it.
I got it.
Okay, go on.
So we'll construct two circles with one with center A and diameter B, AB, and with center B and diameter AB.
Oh, you do not have a
And
compass.
oh, no, but A, B are marked, so we can construct the circle.
No. So, okay, like, let's say this is the point B here, right? You are essentially given one circle with center and you do not have a compass. So, like,
Okay.
yeah, so you cannot construct this circle. Okay. So, Male, would you like to say your proof?
Yeah, so consider points B and C on L.
Okay, let's just consider it says E and F.
Okay, fine. And now draw line EA.
Line EA. The point of this is, you know, the midpoints of these two things.
Yeah.
On this line.
And now we know midpoint of GH is A.
I'll just label them as you want.
E1, E2.
Yeah.
Yeah, and now consider the segment E1, E2, and we know its midpoint. So we can draw a line through F parallel to E1, E2.
Yeah. So basically on this line EA, you have a bisected segment. So you can construct any line parallel to this thing. Nice.
Yeah, and similarly do FA cap the circle.
Yeah. So similarly, you consider this thing and you will have a bisected segment here. So you can construct a parallel line through this thing also.
Yeah, through F parallel to E parallel to FA, and
Yes.
they intersect at say.
And now notice that this thing, GEAF is a parallelogram. So they'll intersect at the midpoints. So
Yeah.
you get the midpoint of EF. So is this clear to everyone?
Yes.
Yeah. So the basic idea is you need to use the things which you discovered previously. So we discovered that we can construct parallels if you have a bisected segment. And you need to construct midpoints. So you try to look for the most natural midpoint thing in the configuration, which is a diameter. And now like you just take random point. And I think after that it like follows with like enough hit and try, you can say. So we can construct a bisected segment. So basically what we can do now is we are given a line L. We can construct line parallel to L, right? Like just take 2 points, you can construct the midpoint of those 2 points, which means you can construct a line parallel to L. So we have the parallel tool. Okay. What is the natural thing to consider after parallel lines? Okay, it might be natural to some people, might not be to other people, but it like suits with parallel lines. Like any guesses or something?
Parallelograms.
Sure, you can draw parallelograms. Like we just draw parallelogram here, right? To complete this thing. Okay, perpendicular lines, basically, if that would make sense. So can we construct? Yeah. So can we construct perpendicular lines? So let's say you have this line, EF. Can you construct a line perpendicular to EF through any point? Like let's say I just construct the line perpendicular to EF through this point. Then I can just construct parallel line, right? So I can construct anywhere the perpendicular. I'll just take a parallel of this from that point. So like a perpendicular at any point, passing through any point. Like go with the basic idea which I told. Translate the things you have to circle. Try to do the things in circle, because in circle you know the center, and there are more nice things in a circle than just in a random plane, right?
Yeah.
Yeah. Okay, also if anyone gets it, first just like tell in chat, like just don't directly say it. I want other people to think about this for a while. Oh, I should have said this in the starting. It would be nice if more people can turn on their cameras so that I know the reactions of people. So you only have a straight edge and a circle with center mark. You need to construct a line parallel or perpendicular to a line. And you can construct parallel lines. We have proved that. Is it clear what the tool is? Intersect.
Yeah.
Okay. Oh yes, that works, Millet. I had a different proof in mind, but that works too. Okay, does anyone have any ideas except Malay? Like speak anything, whatever you are trying. Like it's fine even if it doesn't work completely. Okay. So fine, I'll just tell it. So the basic idea is to like translate the thing to the circle, right? So you just construct a parallel line, a line parallel to this, passing through any point on the circle. Like let it just intersect the circle, nothing else. Now, can you construct a line perpendicular to this line GH?
Yes, similarly we did in the past.
Can you repeat, Sudhanshu?
In the previous question, we can get the bisector of the GH. The line which will bisect GH will from A through A will be perpendicular to GH.
Yes. So essentially, like if you just construct the midpoint of GH, we know the line AI is perpendicular to GH, right?
Yes.
Yeah. And now, since GH and EF are parallel, this line will also be perpendicular to EF.
Yeah.
Nice. So is this clear how we can construct perpendicular lines? Yes, no?
Yeah, okay. Yeah.
Yes.
Yes.
Yeah. Okay, at any point you have doubt, like just ask, because in first go, like these things seem to be complicated. Okay, let me see if we can do a question with this much. Just a second. Excuse me. Okay. So let's try this problem. Like this thing, Consulate Steiner is not done, but we'll do a problem first, which uses a similar structure. So you have a circle marked. The center of the circle is not given. Remember, you just have the circle. You are given 3 lines. and which form a triangle. Let's say the triangle is FGH. So what you need to do is you need to construct a triangle in this circle which has lines parallel to these three lines like FG, GH, and HF with circumcircle this thing. Is the question clear? And you only have a straight edge to do this. Is the question clear?
Could you repeat like
Okay.
we are given a circle and
You are given a circle and three lines. These three lines FG, FH, GH, which form a triangle.
okay.
So what you need to do is you need to construct a triangle with circumcircle this given circle, and the line should be like lines of the triangle should be parallel to these three lines. So essentially, you need to take this triangle and construct a similar triangle to this thing in the circle with lines parallel. Does that make more sense?
Yes.
Yeah. And the tool you have is only a straight edge. Okay. I'll just fetch up the original statement of that also helps you. Problem number 4. I hope this is more clear and coherent. So if you can see, the structure here is similar to Steiner-Ponsonby or Ponsonby. I forgot about it. Steiner-Ponsonby, except the center of the circle is not marked. So what is the first thing you try to do? Yes. Also, I can just if that is fine by you. So like we just saw structure, right? Where we have a circle with center and the same tool. And in that thing, we had center of the circle. So we'll try to mark the center of the circle. So that like, does it feel intuitive after seeing the previous thing? That why we want to mark the center of the circle? Yes or no?
Yes.
Okay, other people? Okay, so Nana, you are just done with the problem. Fine. That is essentially the whole proof. Okay. Other people, is it clear to you? Yeah. So, yeah, how do we mark the center of the circle? Try to think about that. Okay. For marking the center of the circle, you don't need these things for now. So let's just forget about this thing for now. Like you just have a circle and a straight edge. How do you mark the center of the circle? Essentially, Malay, yes. Okay. How do I motivate this? What things you know about the center? Like, just state me random facts which you have learned in school. Like, don't be shy. Like, if you're shy, just type in chat. I want to see responses. Like, random facts you know about the circles. I'll just state the facts which come to me in the chat. I won't say the name if you're shy or anything. But like, say something. Facts about center of a circle. Like, what do you know about them? Something like it's equidistant from all the points on the circle is also a fact. Those kind of things. It is midpoint of a diameter. Yes, that is a good thing. How else do you relate midpoints of things in circles with center? So, like, see, I'll tell you the main thing in construction geo is you need to see the points which you're thinking to construct and think of synthetic properties about those points. Even the most basic properties can help you construct the things. So, and in this thing, I'm telling you it's the basic thing. So just tell me the properties. Any chord is perpendicular from the center at the midpoint. Yes, that is a very good property. We'll use these two properties basically. So you have a line, like you take a diameter. It's the midpoint of the diameter. So A is midpoint of FG. What else do we know? We take any chord. Let's say this chord, and the midpoint of this chord lies on this. So basically we have two chords, midpoint of those lie on the perpendicular line through those chords. So it feels like somewhat in, okay, I don't know if it's intuitive or not, but like, you know that if you construct parallel chords and you consider the perpendicular bisector, all of them pass through A, right? Like just consider any parallel chord or any parallel chord, and the midpoint of that lies on this line. So just take any chord, let's say HI and JK. And you consider this thing, JH cap KI. This will lie on the line perpendicular, right? Like this is an isosceles trapezium. And so will this point, IJ and HK. So LM will pass through A. Do people see why?
Yeah.
Yes. So LM will pass through A. So we have one line which passes through A. Now just consider
Oh,
any
yeah,
other.
so do it with any other, right?
Yes. Just consider HF and oh shit. Okay. In the question I should have stated. Sorry, I forgot. I think I showed you the question, so it should be fine, I hope. But he also has a special statement which, given a line L and a point P, constructs a new line passing through B parallel to P. Sorry, I should have stated that before. Probably now it makes more sense. Like you can take any chord, and since you can construct parallel lines, so you construct parallel, and then you mark L and M. So LM passes through A, and you consider any other chord, let's just say HF and some other chord that will also pass through A. So two lines which pass through A, you can mark the intersection and you get the center. So is this clear?
Yeah.
Okay. Is it clear to other people also?
Could we explain the last part?
Okay. So wait till where did you get? Do you understand that LM passes through A?
Yeah.
So now I'm saying just consider any other chord, like not parallel to these chords. Like just take this chord, NO, and take a chord parallel to NO, and do the same thing for NO. You will get 2 points and to join the line which that will also pass through A, right?
Oh,
Like the same thing, right?
yeah.
And so two lines which pass through it, their intersection should be A. So you get the center of the circle. Okay. Thank you. So what do you have now? You have a circle with a center mark. You have a tool which mark the parallel lines. Okay, do you need that parallel tool anymore? We can just do everything with a straight edge, right? By Consulate-Sineathon. So you can essentially do whatever you can do with a straight edge and a compass now. Right? People. Yes or no? Like by this result, we just saw. Like we have not proved it completely, but I'm just saying that you can do everything which a compass and straight edge can do, which a compass and straight edge can do together with a straight edge and a circle with center mark. Nice. So now we have so now we want to transport this triangle into this circle. How do we do that? So okay, yes. So you need to transport a triangle into a circle. So what is the thing you will consider in the triangle? It's circumcenter, right? You will need to overlap the circumcenters. Does it make sense?
Yes.
Yes. So how do we construct the circumcircular triangle GHI? We have everything. We have seen that in Consulate Sineathon. I have just not stated explicitly we can construct the circumcenter, but we can.
We need just the intersection of the perpendicular bisector sides.
Yes. And we can construct the perpendicular bisectors because we can construct midpoints and we can construct perpendicular lines. So just take these things, right? So we can construct the circumcenter. Is this clear to everyone?
Yes.
Nice. So let's say O dash O. So now we have center of this triangle. Now, what do we do? Okay, so first let's just translate this triangle such that the circumcenters overlap. So basically, consider this AO dash thing. Like we need to translate. Okay, does it make sense when I say that we need to translate this triangle such that the circumcenters overlap? Like construct a congruent triangle with circumcenter A instead of O dash. Does this sound more like reasonable interpretation?
Translate the figure.
Like yeah, you need to translate the triangle, not the whole figure, because then it's just equivalent. Just the triangle to this area.
Yeah.
Right. So how do we do that? Basically, you know that O dash. So you need to construct a point through A. Like so you need to construct. So like you have point A and O marked, and you need to construct point G in respect to A and O dash. So you know that O dash G is this thing. So you need to construct a point G dash such that this line AG dash will have same inclination as GO dash and same length, like equal basically. So you just basically do the parallel line, like just complete the parallelogram, right? Someone said in the Consulate thing also, you can do parallelograms. So does it make sense that why this should be the translation of G?
Yes.
Nice. Similarly, we can translate the other points also, right? Notice that the sides of this new triangle are parallel to the sides of the original triangle, right? Just because it's a translation. So now what we have is, we just need to, what do you say? Resize this triangle so that it fits into the circle. How do we do that? The center is same. Also, like A is circumcenter of triangle G dash JK. We need to find a triangle which is similar to this triangle. Like, just consider this triangle, AG dash cap this thing. Do you see why these things should be parallel to the original triangle? Like, why is LM parallel to G dash J?
Yeah.
Not you, Malay. Other people. Yeah. Okay, Vedant sees other people. Like, okay. See this. Array. Like, this is the circumcenter, right? So this is some radius R1. This thing is also R1. And AM is also equal. So this is, let's say, R2, and this is R2. So triangle ALM and AG-G are similar. So these two angles are same, and these are parallel. Is it now clear?
Yes.
Nice.
Yes.
So the thing is, now we're done with the problem, right? LMN is the required triangle. So the thing is, this was in like contest problem. So if you have seen, let's say, Consulate Sineathon from before, you just know that, okay, if you construct the circumcenter, that is very nice. Or like, if you construct the center of this given circle, because you have so many things, you essentially have everything what you can do with a compass. So it just feels more intuitive now. The thing is, this is same structure as the Consulate Sineathon, is what I'm trying to say. And it's not necessary to have seen this thing before, obviously, right? Like, yeah, it's just like you see the structure and you do things and things just work out, if it makes sense. Like, it's probably a fun part of geometry, this kind of. Okay, so let's see other things. Okay, do I want to do Consulate? Okay, let's do another problem at first, and then we'll see Consulate Sineathon. So you are given this thing. You have a point A. You have 3 points, A, B, and C. Okay, is this problem and whatever you did in Consulate Sineathon, both the two things clear for now? Like, any doubt in any part you can ask, I can repeat. Two people said yes. 2-3 more people say yes or no. Okay, nice. You have 3 points, A, B, and C marked. You are given midpoint of AB and midpoint of AC. Let's say this is M1, M2. You have to construct midpoint of, you have to prove that using only a straight edge, you can construct midpoint of any segment PQ in the plane. I'm curious, how many people recognize the problem? Yeah, Malay, I got from your face that you recognize the problem. Yes. Okay, you have 3 points ABC marked, and you're given midpoint of AB, M1, midpoint of AC, M2, and you only have a straight edge. Prove that you can mark the midpoint of any segment PQ in the plane. Yes. Yes, Nana. Okay, does anyone else recognize the problem? Both of them have done the problem, so they recognized.
So you can repeat the problem.
Sure. Not sir. So you have, okay, I'll just make another diagram for clarity. The tool you have here is only a straight edge, nothing else. So just consider that you are given a triangle ABC. like straight edges, so you can construct lines. And midpoint of two sides are given. Let's just say midpoint of AB is given, call it F, and midpoint of AC is given, call it E. Prove that given any segment PQ in the plane anywhere, you can construct midpoint of PQ just using a straight edge. Is the statement now clear, Vinayak?
Yes. If we have the midpoint of AB and AC, like, can't we create the circumcircle of ABC, which will be like the
Like you
fixed-
do not have a compass.
Okay, sorry.
Yes. Okay. The straight edge structure is similar to Consulate that's what we're talking. Consulate Steiner. Right. So we did this as the first lemma in Consulate Steiner. What was the first lemma? Anyone remembers? In that thing, we did not need any circle. Yes, Vinayak.
Drawing a parallel line.
Yes. So if you have like a line and you have a bisected segment on that thing. So let's say you have ABF and I give you any other point X. You can draw a line parallel to AB through X, right? Does everyone remember this thing? We just did it in the beginning of the class.
Yes.
Yes. Nice. So we can construct lines parallel through to AB and AC. For now, forget PQ thing. Just tell me if you can construct like midpoint of BC. Like that is the
Yeah. By
yes,
Keva's theorem, we can join CF and B, and their intersection we mark as
that
X.
is, yes, that is more easier than I thought. I was doing some complicated stuff and everything before. Fine.
What did you think?
So okay, I'll just tell you the my proof for midpoints. Construct a line parallel through CA and why do I feel my proof was wrong? No, yes. Construct a line parallel through CA and join CF, meet it at X. Similarly, construct Y. Now, A should be the midpoint of XY and XAY should be collinear because this angle is B, this angle is C, so this is 180. And now you have midpoint of XAY, so join XB and YC to meet at T, then 80 passes midpoint. That is
So
just way more complicated.
It's like the way we try to prove that it's kind of the medial triangle.
Yeah. But yeah, this is just far more natural. Like construct BEFC and then you get the midpoint of PC. So basically, the thing here is, if you want to construct B and C come midpoint, and you have some point A from which you know AB and AC is midpoint, then you can construct BC is midpoint, right? So let's say for now, you have ABC triangle and the midpoints of ABC are given. I give you any other segment AX. Can you construct me the midpoint of AX? Or yeah, can you construct me the midpoint? Oh, someone was saying something. Male, I know you know the problem. No need to do this. Okay, if you want a problem, try this. Let me think. I have a problem for you that would work. Oh, okay, fine. But I'm not reading your code. I'll just give you another problem. Should we have my notes? So you have a compass, and the compass is a result compass. You can preserve the radius of the compass. So, like, do you get the point, right? Like, I mark the radius at somewhere, like we do in normal life. We mark the radius and then we just translate. So you have a rigid compass. Prove that you can do anything which you can do with a compass and a straight edge just with the compass. Or, okay, before that, I'll just give you the claim. Prove that you can convert, draw the inverse of a point X with respect to some given circle and center of that circle. No, you can vary the radius of compass, but it's a rigid compass. You can preserve the radius is the point. Like you can draw two congruent circles easily. You do not need to do stuff for that. Okay. Other people do this. Any idea? Yes, Pranav. Do you know this from before, or you looked it up after my description of the class?
Of course, I knew it before.
Like I didn't know it from before, so I was thinking that okay, I need to play a class on construction zero. I know some problems. Let's just see some other interesting things. And then this thing popped up, and then I read this, and then there was another thing also, like compass equivalence. That you can do anything with a free compass, whatever you can do with a rigid compass. Okay, anyway, let's just not get off the topic. So, how do you construct midpoint of AX? So, let's say you construct a line parallel to AC through X. Let this be Y. Can we construct midpoint of XY? Yes, Sudhanshu, go on. Okay, like to construct the midpoint of XY, just see this. Like AX and these things are parallel, right? And we know midpoint of AC. So just take this point and this would pass through the midpoint. So you can construct midpoint of XY. Is this clear? Oh, people, yes or no?
It's similar to the first one we did, the first lemma way too.
Somewhat, yeah. Like you just have the midpoint of XY. The same idea. Yeah. So you have midpoint of XY. So now if you can construct midpoint of AY, Y is a point on AB, remember. Then you can construct midpoint of AX, right? So how can you construct midpoint of AY? So construct a line parallel through B to BC through Y. Let's call it X dash. You have midpoint of YX dash. Call it some T. Now, how do you construct midpoints on this triangle, AYX dash? But how do you actually do that? Okay. I think I pixel when I did this purpose. This is funny. Fine. I remember. Yeah. So, okay. You have this thing. So what you do is, you know that by midpoint theorem, if you can, you have midpoint this some x point, x t, then TP should be parallel to AC, right? And we can construct the parallel lines because we know midpoint of AC. So just construct a line parallel to AC through P, and that will intersect midpoint of AY. So is this clear? Yes.
Yeah.
Yeah. Other people, or two people said yes. Some more.
Yes,
people.
I actually have another one, another proof.
Yes. Go on.
So we'll join T and X dash and
Oh.
E and Y, and then
Wait, what
we'll
points will join?
F and X dash
F
and Y and E.
and X dash, Y and E. Yes.
So FE is parallel to YX dash,
Yes, it should be parallel. Yes, it's parallel.
and now we'll mark the intersection of this.
Okay, I get the intersection. Then
And so we are done.
how are we done?
Like we'll join the line like 80, like we can mark the intersection of these two diagonals.
You're saying this thing,
Yeah,
and what do we get?
the midpoint.
Oh, like midpoint of YX dash we already had. We need midpoint of AY.
Oh, okay.
Like YX dash is just like YX dash is parallel to BC. So just construct AD, and that midpoint will lie on that
Oh.
thing, no?
Okay.
So the thing is, you have midpoint of YX dash. So you construct a line parallel through AC, which will be parallel to AX dash. So this will be the midpoint of AY. So now you have midpoint of AY and YX. You can construct midpoint of AX, right?
Yes.
Nice. So now how do we construct midpoint of some random segment PQ? So basically notice that what we have is, you have A. You have 2 points, A, B and A, like B and C, such that you know midpoint of AB and midpoint of AC. Then you can construct midpoint of BC and midpoint of any line through A. Right? How do we do this here? Okay, so the idea is basically you construct a line parallel through P to AB. You can do this, right? Some T. And you can mark midpoint of PT also, right? And similarly do it for AC also. And you can mark midpoint of this thing also. So now we can mark midpoint of PQ. Because you have two things which have midpoint through P, you can mark off the third. So is this clear? Yeah, it like in the first one, it seems like how do you even come up with this? But I think like as you see more structure, it feels actually, I don't know. Yeah, so is this clear to everyone? People yes or no, anything?
Yeah.
Nice. Okay. So let's see what else I have. Okay, so we can do the following things now. I'll probably take a part 2 of this sometime later, if people would be interested, because I cannot cover everything at this moment. So we can either complete Consulate Sineathon, this is the first option. Second option is look at Elmo 2020 P3 structure, the pendular bisector one, which I said in the starting of the class. And third is look a bit on Mohr-Mascheroni theorem. Like, it sounds fancy, it's just essentially what I said to Malay, that if you have a compass, compass is superior to compass and straight edge. We can do the basic things in this Mohr-Mascheroni. Okay, people vote, like whatever gets like 4 votes wins. Okay, the value Elmo, I see. Sudhanshu also said Elmo. Krisha was okay. 3 people said Elmo. Malay saying 3. Sunana saying 3. Vinayak saying 3. Okay, so 2 and 3, it's a tie. Okay, 2 or 3. Okay, Aditya said 3. So we'll do Mohr-Mascheroni theorem. Yeah. It's fine, Devayu. If you want, I can. It's fine. I'll take part 2 next week. I'll do Elmo problem that week. Is that fine? Nice. Actually, not next week. I know why then. Whatever. We'll just see then. Soon. Okay, let's see Mohr-Mascheroni. Is the pronunciation correct? I'm not sure of that. So what this thing says is a compass can do everything that a compass plus straight edge does. So essentially, compass is better than a compass and straight edge combined. Obviously, it cannot draw lines, but it can mark the intersection of lines with other things. That is what we need from a line, right? The thing is, how do we define a line then? We just define a line as like pair of 2 points. Like, if you're given 2 points, you can define the line. That is what all what you need to define a line. So let's see some basic things with the compass first. I'll just delete everything because my mirror is lagging. Okay. So someone asked for reflection in the Steiner consulate. Here the reflection is direct. Can you construct reflection of point X over the line AB? Like, you do not have explicitly line AB, but still, can you construct the reflection of X? Yes, you have a compass.
What we can do is like we can set the compass, the fixed point at A and the pencil at X, and
Yes.
we can draw an arc.
Yeah.
And we can do the same thing from B.
Yeah. Yeah, that works.
The same thing from B, and the second intersection point is the mirror image.
Yes. Just give me a second. So what you have is you have AB, like you do not have the segment, but whatever. I'm basically and you have C. So what we do is you consider a circle with center A and radius C, and then with BC, and then this point C dash is the other intersection, is the reflection. So is this clear to everyone? That why there should be the reflection, like you can use congruency if you want. Next. Now, can you reflect a point A over a point B? You're given a point A and given a point B. How do you reflect A over B?
So can you repeat it?
Huh? Go on.
Can you repeat it?
Oh, so you have 2 points A and B. You want to construct reflection of A over B. That won't be the construct like reflection of A over B, right, Aditya? Like, sure. I draw this circle and I draw this circle. But how do you construct the reflection? You still haven't got the reflection, right? No worries. I think it's a bit hard to motivate reflection also in some things. Okay, so what to do is you consider this point C. Okay, let me see if I can motivate it. No, I'll just do this. You construct a point C. Now, if you what con? No, okay. So now, if you have this point D, C and D are in some, like you do not have this point right now, but let's say you had this point. C and D are somewhat symmetric, right? With respect to A, B, A dash. Like as C is to A, B, D is to A dash B. Right? Yes. Can you construct D using A and B? Can you find a nice way to construct D? Malay, check the lens which you're saying equal. They don't seem to be equal at all. We can't draw. Yeah, we cannot draw parallel. Like we cannot draw any lines. We don't even have this line. Neither we have these ones. But we just know that they're equilateral triangles, so I've just kept them. Okay. So notice that AB equals to BA dash. Like I'll just draw everything for now. So notice that AB equals to AC equals to BC, and AB should be equals to BA dash equals to A dash D equals to BD. This angle is 60 degree. This should be 60 degree, and this is 60 degree. So this should also be equilateral. Do you now see a way to construct D? Bro, you said CD equals to CA dash. Malay.
Wait, no, I defined D in other way. D is the second intersection of the two circles.
Okay. Yes, that is equal.
Yeah.
yeah. Uh, can you find a nice way to construct D now without involving A dash? Like these are equilateral triangles. And we can construct reflection of point over a line. Yes, that is correct, Aditya. So notice that D is reflection of A over BC. So you can construct D. And then C will be the reflection of A dash over BD. So reflect C over BD and you get A dash. So is this clear how we can reflect points? Okay, kind of Aditya understood other people.
Yes.
Yeah. Okay.
Yeah.
Now I regret doing Mohar Master only because I just said your name by mistake. Sorry, Kanna. Like I was just checking, are you still there or you left the meet? And then I want to say Aditya, and then I said your name because it was on my mind. Yeah, we know you exist. Okay, now I regret picking Mohar Master only because I should have specified that you should have a bit of inversion experience.
Solving the Mohr-Maslow theorem, don't you have to just like prove 4 cases possible, like to draw a circle with given center radius, to find points of intersection of 2 circles. Case 3 is to find the points of intersection of a straight line and a circle.
Yes.
And to find the intersection of 2 straight lines only using the compass.
Yes.
The first 2 are easy or are clearly possible.
Yes.
Case 3 and case 4 is just what we need to prove.
Yes, but those are not direct, right? So I was just like building on the structure. Also, like in general, whenever you say construction 0, don't just directly go on proving the result because like in most cases, it's not that direct. You first need to see, okay, what all can you do with the tool you have? Like even if it's not related directly anyhow, just try to randomly play with the tool. So if you play, then you see, okay, reflection of a point over a line is obvious. And then you notice, okay, if you construct reflection of a point over a line, can you construct reflection of a point over a point? Those two feel that way. And then you try to see what other things can you do. I don't know how you motivate inversion in the next step. That is what Wikipedia proof says. I have no idea. But that is needed to prove intersection. Okay, one way to motivate this is, as Vinayak said, you need to mark intersection of 2 lines to prove a compass is better than a compass and straight edge. But how do you relate lines and circles? Like lines go to circles under inversion, right? Unless they pass through the center of the inversion, ignore that case. But lines go to circle under inversion. So that way inversion is somewhat nice, if that makes sense now. So is that fine now?
Yeah.
Okay, how many people here know basic inversion? Okay, if people don't know, I still have 7 minutes. I'll do one case of Steiner Consulate and we can continue the Mohar Master only later. Okay, 4 people know. Kanam, I'm assuming yes, 5 people. Aditya also knows 6 people. Okay, so is it fine if I continue the Mohar? Sure, Kanam. Did he actually not know his joke? That is terrible. I took 2 classes on inversion. You should attend those. So yeah, people do know. So is it fine if I just do the next part of Mohar Master only or one thing in Steiner Consulate? I can do either. I can do only one thing. I can do this. Okay. Do Mohar solve the bio. Thank you for the chemistry offer. Not interested. That was the first thing I thought of when I also read the theorem. Okay. So the next thing is, you are given a circle AB. You want to construct the inverse of some point C with respect to this circle. Or center of the circle is marked. How do you motivate us? That is a good question. Okay, try for 3 minutes, else I'll just see the proof. Pranav, you know this thing. Can you tell me how do you motivate this?
What? Sorry.
How do you construct inverse of a point with a circle?
Tangents?
How
We
do you construct
can,
tangents?
I
Bro.
think I know how to do this.
Yeah, go on.
We can, how do you say this? Let's put a compass on line AC.
1 second. Can you construct midpoints in this thing? Okay, I haven't thought about that. Okay, if you can construct midpoints, then it's fine.
Yeah.
Can you construct midpoints? Okay, no, then I go on with your things.
Like if we draw an arc with center at C, arc AC, where it intersects the
Wait, do you know this
original
from before?
circle. Yeah, I do.
No, it's fine. Then I know then you will be able to do it. It's fine. Anyone else? Okay, can we construct midpoints? That is a good question. If we can do, then it's
Yeah, then we can.
we
Mark
construct the
inverse.
tangency points.
Yeah.
And oh, then you can mark the midpoint or the tangency point, and that is the inverse. Yes, but you need to construct midpoint. Okay, so the thing is, the inverse is basically you take the tangents from C to this circle, and then the midpoint of these 2 points is just the inverse of C. That is how inverse of C will be defined, right? Is this thing clear to everyone? Yeah. So now, if you can construct midpoints, then consider the midpoint of AC. Consider a circle with center F and radius A. You'll get the points D and E because ADCA is cyclic. And then you can construct midpoint of DE, that will be the inverse. So we just basically need to see if we can construct midpoints or not. Mali, you got that we can construct midpoints, right?
Yeah, I'm trying.
You're trying or you got it?
No, I'm trying.
Bro.
I just thought we can.
Okay. Midpoints. Like the thing which I had in mind is it's like unlike like when I was even thinking or before like preparing for class, I was like, okay, let's say you have a segment GH, you construct some circle, and the midpoint lies on this line. You know that. But the thing is you cannot construct a line. And you need to construct intersection of 2 lines, for which you need this inversion thing. So I don't think you can directly construct.
Oh, we can call the intersection of these 2 circles as whatever, X and Y. Then draw a circle with diameter XG.
1 second, bro. How do I resize this thing?
If you can't draw that.
Okay. Yeah.
Oh, wait,
draw what?
you can't draw circle with diameter. Sad.
You do not have a cyclos, Malay.
Sad.
Yeah, we do not have a cyclos.
Yeah.
Okay, but what happens if we draw this? Array. Like I know the proof, but I'm just trying to prove it in another way. Okay, don't judge me for this. Like, okay, these 2 points lie on this line. No, this just looks nice, but nothing is. Sure, I have an analytic proof. You can just keep on doing this until you get the midpoint. That is just terrible. Okay, no, fine. You cannot do this. we'll just go by the scam rule, which I don't know how to motivate by the way, people. Okay, probably I know how to motivate it somewhat. So what you do is you construct a circle with center C and radius CA. You construct these 2 points, D and E. Now, no, what is the inverse of this circle with this circle? It's the line DE, right? And if a circle goes to a line, then the center of that circle goes to the reflection of the center of inversion through that line, and you can construct reflections. So this will be the inverse.
Oh my God.
You can prove this using inversion distance formula, if that makes sense. Okay, the ending of the session was terrible. People, is this clear to you?
Yeah.
Malay, I see it's clear to you, other people. No, okay. So do you know this? Like, let's say I have a circle and I have another circle. I construct the inverse of this circle with respect to this circle. If it's a line, then the inverse of the center of the circle is reflection of A over this line. You can try to prove this using inversion distance formula. Yeah. So using this fact, we can construct the reflections, right? So we just get the inverse. Is it now fine by you? Yeah. Other people, is it clear? Like people who don't know inversion, just forget the last thing. If everything else in the session is clear, that's also good. Yeah, so that was it for the session. I hope you like the constructions your part and like how it's natural and like fun to play with the tools.
Yeah.
If people have doubts, you can ask, and
We need part 2.
thank you for that. Yeah, I'll probably take one next week or next to next week. And then I'll just finish. Okay. To those who are interested in part 2, learn inversion, like for more master, like basic of inversion, it's fine. You do not need root BC by 2. Just basics of inversion. And in part 2, I'll probably do this first. I'll probably complete the Steiner-Poncelet and Elmo 2020 P3. And if I get time, then only I complete more master only. So even if you do not learn, you'll only not understand the end of 15 minutes in the worst case. So that's up to you. But you'll understand the other 2 things. So yeah. Okay, I'll stop recording. Yeah.